Hello, Jeters. We're back. Let's just test the chat. I've got the chat off screen. Stream. Testing chat. Looks like chat's working. All right. This morning, welcome everybody. It's 6:47 a.m. on Monday, I think, in Northern California. And I'm rocking out with Dream Clinic Automata. Same thing you're seeing on your screen here. I think it's arguably my new favorite YouTube channel. Wow, these guys are good. For me anyway. So if you like kind of dark ambiance with a little bit of a beat, but not too distracting, definitely check it out. But now that we have that out of the way, I want us to continue from last time and talk about, I was able to track down the MIT article. I told you we had a copy somewhere. I found it. And so we're going to quickly go through this guy. And I'll ping Will again and see if we can get this paywall removed. But, you know, I mean, in some sense, it's pretty cool in that I think that means the article's being viewed and read quite a bit. But on the other hand, it's like a little bit of a bummer because, you know, it is MIT and it would be nice if the whole world could read it. Kind of like these GTT episodes. Anyway, we'll see what happens. So we're going to talk about that. Then we're going to get into this AI slop conundrum. And the truth is, I was like maybe a little bit aware of this. I mean, AI slop, sure, right? That's pretty obvious. We've been talking about this for a while. But I'm specifically talking about the AI slop conundrum. The conundrum part. And maybe we'll watch this short, or just short, to get up to speed. And then I want to talk about what this means, because while I don't have an answer to this, it's becoming at least somewhat obvious to me that this is going to, I think this has the chance to impact all of us. And it's not looking good. So I want us to discuss this, and I need to think more about this. I do have some ideas on how to deal with it for machine programming, but it's not just machine programming. It's sort of the entire space of AI. And in fact, for Merle, it probably affects us maybe the least, because we use things like semi-trust for our self-supervised learning, whereas a lot of people, I think, don't. And those are the ones that I think are most at risk. The problem, though, is, like I was saying, this, I think, affects potentially all of us, as hopefully will become pretty clear. So those are our topics for this morning. Let's see what we can get through. And so grab your headphones, like I've got. Get some good background music. Get your caffeination. That I've got. Big surprise. Coca-Cola, whenever you're ready to sponsor me, I'm willing to accept that sponsorship. minimally, you guys can give me at least free Coke Zero, right? And away we go. Let's get started on this. So the MIT article is this guy. Make this a little bit bigger for us. We were trying to track this down last time, and we got paywalled out of it. I'm not going to read this whole thing, but I wanted to get into the parts where I think I was mentioning some of the things that we're doing at Merly, which is a bit different and breaks us out of, I think, some of the dangerous stuff that a lot of the other folks are doing, such as software development, principally using language models. And here we can, actually, let's start at the top here. Okay, ask people building generative AI what generative AI is good for right now, and they're really fired up about what they're really fired up about. Many will tell you coding. That's something that's very exciting for developers, chief scientists at Anthropic. It's really understanding what's wrong with code, debugging it. Yeah, I agree with that. That's a pretty good take, Jared. I like it. Copilot, a tool built on top of OpenAI's large language models and launched by Microsoft-backed GitHub. Microsoft-owned GitHub in 2022 is now used by millions of developers around the world. Millions more turn to general-purpose chatbots like Anthropic's Claude, OpenAI's ChatGPT, Google's DeepMind, Gemini for everyday help, and many other things. Yeah, and some of these claims are a bit, I don't know, there's, as we talked about last time, there's like a lot of hype, I think, that happens with some of these statements that folks make. And I don't love it, because I feel like ultimately it does a disservice because it misrepresents reality. But if we look at what Sundar Pichai, I think, was saying, it says, today, more than a quarter of all new code at Google is generated by AI, then reviewed and accepted by engineers. To be totally honest with you, I think that that's probably at least an order of magnitude exaggeration. And they're doing things like anytime the AI does autocomplete, anytime they have to look something up, they're claiming it's AI, mostly just to inflate the numbers. On top of that, they're requiring that almost all engineers, or every engineer at the company, and not just at Google, at Microsoft, Amazon, and elsewhere, use these things so then they can report these really exaggerated numbers. Again, I think that they're doing themselves a disservice because they are hyping the technology as essentially having a level of maturation that it doesn't actually have. And I understand the goal here could be to increase the market adoption, but I don't think selling people these stories that are not really based in reality is a good way to do that. I think, keep that beta testing tag on things. And then we have this helps our engineers do more and move faster. Yes, it is doing that. It's definitely helping them do more, and they are moving faster, even if they are moving with less care and less quality. Speaking of which, there is this exciting drama in Linux Foundation with, how do I get to this? I think it's Linus plus somebody on a massive commit. Maybe we'll take a look at this. So anyway, now we move on. It's not just the big beasts rolling out AI coding tools. A bunch of new startups have entered this buzzy market too. Newcomers such as Zencoder, Merly, Cosine, Tessel, valued at $750 million within months of being set up, and Poolside, valued at $3 billion before it even released a product. Okay. Are all jostling for their slice of the pie. It actually looks like developers are willing to pay for copilots, says Nathan, an analyst at investment firm Air Street Capital. And so code is one of the easiest ways to monetize AI. Okay. Such companies promise to take generative coding assistance to the next level. Instead of providing developers with a kind of supercharged autocomplete, like most existing tools, this next generation can prototype, test, and debug code for you. The upshot is that developers can essentially turn into managers who may spend more time reviewing and correcting code written by a model than writing it from scratch themselves. Okay. Yeah. All right. But there's more. Many of the people building generative coding assistants think they could be a fast track to this is such an overloaded, silly term. The hypothetical superhuman technology that, yes, so AGI, like it's actually kind of interesting because now most of the people are backing away from AGI because it's like a little bit nonsensical. Superintelligence is, I think, different. Just a little background, at least from my perspective. Artificial general intelligence, I don't actually know what this means. Like, what does it mean to be generally intelligent? Like, how do you decide this? How many fields do you have to be generally intelligent in? 7, 35, 12? And then what is the discriminator for intelligence for those areas? Like better than what, for example? Whereas something like superintelligence, which tends to be restricted to like a single domain, it's usually very simple to define in that you try to show that a system is potentially better than the best humans on the planet. And in fact, we already have sort of like superintelligence systems, like this system that I just brought up that I can't move now because of the way this thing is blocking it. If I can do, no, I can't. Okay. Oh yeah, look at that. Here's a superintelligence for you. And this thing is going to likely be better at mathematics, or at least basic arithmetic, than any human. Possibly. But superintelligence, I think, can actually exist. And I think that is interesting. And I also don't think that there's an association with superintelligence and like the destruction of humanity or anything like that. So anyway, let's continue. For the first time, we will see a massively economically valuable activity to have reached human level capabilities. Wow. Okay. Hold on. Let me try to read this again. The first time we will see a massively economically valuable activity to have reached human level capabilities will be in software development. Yeah, maybe. I try to stay away from strong claims like this. We're already seeing a lot of economic value from AI, and it doesn't have to reside in software development. But I do think that software development is a good target. Okay, so then we go on to talk about stuff, but I'm just going to jump to, I think, where contrarian Goju comes into the picture. So we start off and they're talking about a bunch of cool things and what these guys are doing. And then at some point, I think it's, when we start talking about gaming the system. Oh yeah, here we go. Yeah, of course, not everyone takes that view. What view? A view is this. I personally have a very strong belief that large language models will get us all the way to being as capable as a software developer. Yeah, so I suspect all of you know I don't have that view for various reasons, mostly that are scientific, not opinions or emotions, just a deep and nuanced understanding of neural networks and their lack of logical components that would give them the ability to function as intelligent systems more than just stochastic parrots. So, of course, I'm going to come in here and talk about. And by the way, like I when I'm talking to Will, I don't know who he's talking to. I'm just telling him what I think. So to Goju, a large language model is the wrong tool for the job, period. He invokes his dog. No amount of training for my dog will ever get him to be able to code. It just won't happen. That's not the full quote, Will. He says he can do all kinds of other things, but he's just incapable of that deep level of cognition. Okay, admittedly, yes, I probably did say exactly that. But I also said, I love dogs. I'm going to give you the full quote. All right. I've got it recorded somewhere. I'm going to play it back so you can hear the snippet. Right. We both recorded the call for posterity's sake. I said, first of all, I love dogs. My dog, Merle, is the mascot of our company, and we named the company after him. And he can do a number of amazing things. However, due to his cognitive limitation, it would be mentally impossible for him to write software code. This is my strong conviction. And no amount of training would likely ever get him there. And that there are cognitive limitations on different entities that are real. Right? So this stuff is fairly well known. This shouldn't be super shocking. And it's not to say that humans are so amazing because we have this ability to think complex thoughts. Humans also have weaknesses that other creatures don't have, right? Other creatures on this planet run faster than we do. They're stronger than we are. They live longer than we do, like parrots and turtles and things. And so there's just it's just different stuff. But one of the reasons why humans, I think, are potentially at the top of the food chain is for our ability to think deeply, in particular to strategize, so we can think out like the long game. We can do things like play chess and even more complicated things like plan our lives over a long period of years, maybe even decades. And then on top of that, one of the other strengths that we have is our ability to collaborate with other humans and other species, like my dog. He and I collaborate. He has a job, I have a job, and it's great. It's very symbiotic. Now, when we think about these language model things, we know that, as we've discussed before, they don't inherently have these reasoning capabilities, these system to thinking things, as is described in things like thinking fast, thinking slow. So in order to do things like long division, you really need that type 2 thinking. Okay, so let's continue. Having worked on code generation for more than a decade, Gotchlick has a similar sticking point with large language models. So, and it's true, as I'm trying to draw the parallel that my dog can't do it, even though he can do a bunch of other stuff. But he doesn't have the cognitive power because he doesn't like understand the meaning of the symbols, like the actual meaning, not just a parroted meaning. And so I believe that language models essentially have the same thing. This doesn't mean that all AI has to be language models. And in fact, this is why Merle's AI is not using these systems. And it is a semantic reasoner. And it does things that fuses those 4 domains of machine programming together. So programming requires the ability to work through logical puzzles with unwavering precision. No matter how well large language models may learn to mimic what human programmers do, at their core, they are still essentially statistical slot machines. He says, I can't train an illogical system to become logical. I can't. I don't know how to do that. If it's not logical, I don't know how to make it logical. It needs to be logical by default. It's the whole idea of I can't build a house that is going to be stable unless it has a foundation underneath it first. No amount of balancing and doing the right thing is going to give it that foundation. You have to have that foundation in place first, and then you have sort of the basic framework in which you can build on top of. And the same, I believe, is true here. You have to have the logical components at its core, as we've discussed many, many times. And then from there, you can do a bunch of things. A lot of that is also the basis of mathematics, programming languages, and other logical systems like first-order logic or many of the constraint-solving systems. And what I mean by that is they often have a constrained and precise vocabulary that only allows symbols that are formally defined. And a very simple example of that is software programs. Just think about code, right? Because most of us here are programmers, I suspect. And in software code, you have a whole bunch of these symbols. Symbols can be variables, function names, classes, all that stuff, right? So those are all symbols, and every one of those symbols is formally defined. What does that mean? Well, it has like a definition. The variable is like it's an integer, or it becomes an integer when it's assigned an integer. And a function is like it has a body. And so when you call the function, it executes the function body. And then the body of the function says, these are the instructions, and I'm going to do this. And anything that doesn't have those things would just crash the program. Why? Because it's undefined. You just don't know what it's doing. And it doesn't know what it's doing. And so that's why you can't do like x divided by 0. Why? Because it's undefined. We don't know what that means. What is 12 divided by 0? Infinity? Negative infinity? Like nobody knows. We don't know what it means. And so it's undefined. You just can't do that. And notice that all the other numbers that I'm aware of in continuous systems or discrete systems can be divided by those numbers. It's just this one special case of 0 that we're like, yeah, I don't know what this means. But it's super important that that's defined. It is defined that it's undefined. It's not that we get to the point where you divide 0 and you're like, well, roll the dice. It's 37 this time. No, it's just like, you can't do this, right? So similarly, when you are creating a logical system that you're going to use to do logical things, you have to have in my view, and I think the scientific community would largely agree with this, the foundations of these types of logical definitions in place. Otherwise, you don't have a logical system. And with natural language, which is what a lot of these language model systems work in, you have a lot of stuff that's not precisely defined. And again, works great for soft science, doesn't necessarily work great for hard science. And so you need like a different model. Does not mean that you can't use LOMs, language only models, on top of these logical systems. It just means you can't use them as sort of the base system. Okay. So instead of training a large language model to generate code by feeding it lots of examples, Merle does not show its system human written code at all. That's true. That's basic. That's because to really build a model that can generate code, Gottschalk argues, you need to work at the level of underlying logic that code represents, not the code itself. Merle's system is therefore trained on an intermediate representation, something like machine-readable notation that most programming languages get translated into before they are run. So again, Will has a PhD in computer science, so he's super seasoned. For people that don't have a PhD in computer science, this might seem somewhat confusing because oftentimes, historically, when you have intermediate representations, these IRs, it's usually like it could be used as a system to lower the code to a lower representation to get it to like assembly or eventually machine code. But as we discussed in some of the prior episodes, you don't have to create IRs that go down. You can create IRs that go up, that then take the syntax and move it upward so it has semantic representations. It converts things that are largely syntactical into things that have semantic meaning. And that's what we're talking about here. And it is true that Mentor's system, Merle's AI system, actually doesn't reason about human written or maybe even AI written code at all. It does a transformation on this and then transforms it into something that we believe is far more meaningful and then reasons about it at that level. It's like the analog here could be considered something like the tokenizers for language models, but it's far more complicated than that. The tokenizers, I think, are, well, yeah, I guess maybe I'm not allowed to say too much about that. Oh, yeah, here's proof I'm not allowed to say about that. Gottschalk won't say exactly what this looks like or how the process works, but he throws out an analogy. There's this idea in mathematics that the only numbers that have to exist are prime numbers because you can calculate all other numbers using just the primes. Take that concept and apply it to code, he says. Yeah, exactly. And I would love to go into far more detail about this because this is, I think, a really interesting idea, but I don't think I can at this time. But this is a real thing. Not only does this approach get straight to the logic of programming, it's also fast because millions of lines of code are reduced to a few thousand lines of intermediate language before the system analyzes them. This is true. And again, the prime example is meant to illustrate that, is that you don't need the massively large set of composite numbers you just need the primes, which is a subset of that larger superset of composite numbers to represent all the composite numbers. And so if you have whatever the maximum composite number is, and then you find all the primes from that number to 0, you can represent all the composite numbers with just those primes. That's like how it works. And so if you had all those primes, then you would reduce the grammar, you would reduce the spatial overhead, you'd reduce the analysis, you do a whole bunch of stuff. A lot of different things. And this is one of the ways that the mentor system can be 6 orders of magnitude faster than language models. It's not magic. It's very similar to what Google did when they entered search, is that, as I understand it, Microsoft, Yahoo, Alta Vista, and others were doing web search principally using high-performance computing on a single node, and it was all just everybody doing basically the same thing. And Google said, well, you could actually do this a different way, and you could use commodity hardware, and you use concurrency and distributed computing in an algorithm that at least fundamentally can be thought of as map reduce. And then you can make things much, much faster. And in fact, I think the Google example is something like 6 orders of magnitude faster. Hey, Ivan. Excellent. 6 orders of magnitude faster than the existing search engines at the time. And it wasn't magic. It was just what happens when you have a fundamental architectural difference in technical approach. And it's similar with what we've done. And so you can probably have an intuition on how this might, just taking just this prime example, on how this might give you massive performance benefits. And it's not just that. It's many other things. It's a different machine learning algorithm entirely. It's not neural in nature at all. So it doesn't use neural networks, not the core system. And then also there's optimizations related to things with system architecture, so hardware. Anyway, let's continue. Yeah, so talking about this whole the number inflation on the way these companies work with using their products. Here's concrete evidence. In November, Cosine banned its engineers from using tools other than its own products. So basically, as I understand it, almost all folks in industry are following a similar principle. What does this mean for the energy efficiency? Hey, Lisa. Yeah, so it's a fantastic question. We have a slide deck that actually talks about the energy efficiency, and essentially we see a similar reduction in the compute cost as the the energy cost as the operations that you have to perform. So it's essentially several orders of magnitude more efficient from an energy perspective. To give you a concrete example, you can perform full lifetime inference on a repository. We'll just log into Mentor here. And let's say we just pick Git. So this is Mentor. And it's performing inference. Actually, let's pick something bigger than Git. Is Kubernetes on this one? Yeah, okay. Kubernetes is pretty big. So here's Mentor performing analysis on Kubernetes from 2014, 2024. So this is like 10 years of inference. And Kubernetes is about 4 million lines of code. Let's just split the difference. We'll just make the math really easy. I think there are about 50 points here. So what is that? It's like 200 million lines of code, I think, that are being inferred on this. And we can do this on a single node commodity hardware, just like an Intel Xeon. No GPU is required. And it takes on that single node approximately like 2 to 4 hours. So we have some slides that show the actual time difference and the computational efficiency. But it's something like if you were to use language models, it would take on the order of maybe 5 years, 5 to 10 years to do what Mentor can do in approximately 2 to 4 hours. And again, it has to do with many things. One is the underlying architecture is not using language models. The second is we don't use traditional tokenizers. We've invented new intermediate representations that translate the code into their semantic meaning. So, hey, thanks. Yeah, and I think there's a video on this where, oh, look at that. I just happened to be wearing my white hoodie today. Yeah. There's a video we were talking about in the last episode where the vibe coding, I think, is those days hopefully maybe done. Yeah, so the way that I teach this at the university is it's really a fusion of these 4 areas. And what we see in sort of the startup space today is there's a lot of emphasis just on this machine learning piece, which I get. For a lot of people, language models and neural networks are sort of like the shiny new toy. And it is really exciting. And transformers, I think, are fascinating, especially when you use them for things like soft science, natural language, things that are open to interpretation and are subjective. Not super great, in my mind, for hard science. And so what we do at Merrily is our technical approach is a fusion of figuring out how to make advances in all 4 of these areas simultaneously. And these 4 essentially are the foundations for the Mentor AI system that you see here. And that's why you get this massive speed up. But you don't have to actually believe me. There's an episode where Taylor and I think, are showing this, and it's like running in the background. And yeah, it's this one. 5 million lines of inferred code in 5 minutes. And then there's another one. Oh, this is the shorter one that people seem to only 700 people or views on this one, but 100,000 on this one. I guess they liked the 2-minute version. But this one, you can see Mentor actually doing inference on 5 million lines of code in about 5 minutes. And it's actually faster than that, but this machine is doing a whole bunch of other things. We've given a couple live demos. We gave one at Monty. I think I was okay. Well, anyway, if I just, I think that it's like the shorter, but maybe there's a recording of it. But we also did like a live demo of it there. But check it out, yeah, and feel free to ping us directly. We'd love to give you a demo or show you some stuff. Okay, cool. So back to MIT stuff. So we've got cosine banning its engineers from using. This is actually pretty much like what everybody's doing. Okay, so everybody, that might be too strong of a claim. A lot of people. We don't actually have this. Well, we sort of disallow the code generators at Merrily for any of the system level things. But if you're working on higher order code like JavaScript and such, then since that code is visible anyway, like you can just you can just go to things like Mentor and view the source, and you essentially have some of the JavaScript. So anyway, I'm doing my typical meandering. Goju, stay on topic. Okay, here we go. So I wanted to just get to, there's one other part on this, which I think was like, oh yeah, here we go. The warp drive stuff. This is me going all in. And truthfully, this is really what Merle is truthfully about in my mind. Because my view of machine programming is it's going to help us create software faster and with higher quality. But it really needs to be those two things together. Faster alone is just potentially slop, and quality alone, but that's really slow, I don't know, is helping us beyond what we have already. So you really need those two things in tandem. That's at least my view, and that's the way that I was sort of driving this when I was at Intel back in the day when I was running my research lab. It was really those two things, the time and the quality. And that's how I teach it now at the university, and that's how we do it at Merle as well. So it's those two things. And so then why do you really need those two things? Well, in my mind, I think we need to get to Mars. Okay, this sounds probably pretty crazy, but hear me out. Whatever we think may or may not happen, I probably sound like a conspiracy theorist. Whatever we think may or may not happen with AI, I think it's still wide open. And I've been doing these AI systems, as we talked about last time, for like 2 decades, right? And yes, I think that you could have rogue AIs that do things that are not great. But the idea that they're going to turn into Terminator on their own without some principled guidance, I think is unlikely. However, it's sort of an inevitability that there is going to be some kind of catastrophic event at some point that's going to make the Earth unlivable. Let's just assume that that's going to happen. So, minimally, we should be a multiplanetary species. I think the core challenge that we have in front of us to become a multiplanetary species is software, because software is what runs the world. Software is what's running this stream right now. Software is what I used to create this PDF. Software is the stuff that runs all the AI models. Yes, it's hardware as well. But when you think about building systems that are going to support interplanetary species, that's a lot of systems that we have not even started to build yet. And instead, what we're building are like more social networking things. Not that those are bad. I mean, this is a social networking thing. We're all getting smarter, I hope, or at least having open discussion with this. So that's great. But who's going to write the life support systems and the trajectory course correction systems and the three-dimensional fabrication systems for, I don't know, different types of density of materials that need to be built or extracted? There's a lot of stuff that we need to do. So machine programming systems, I think, are going to help us with that, because they can handle, once they get really fast and they get really high quality, they can handle a lot of this for us. And then the humans can spend their time on the higher order ideation, which is how I actually think we'll be spending our time. I don't think that humans will ever be removed from the picture. In fact, what I teach at the university is that whether we're coding or not, I mean, I hope that I'll continue to code for forever, but my view is critical thinking is always going to be necessary, because this is what helps us understand what it is we're doing. This is kind of the reason why I think the vibe coding thing is maybe not super great, is people are sort of deferring to these AI systems to do the critical thinking for them. Is like, put together this website and just do some stuff. But they haven't really thought critically about the details of these things. And then the AI system is making some judgments, maybe some really bad judgments on what those things should or shouldn't be. And if they had like a better and more precise specification language that's not natural language, that doesn't allow for that ambiguity, I think we could be able to produce potentially better software systems. They probably still, you don't want them, I think, to be foundationally driven by language models. But language models can play a role, very much like it does with Mentor. You know, Mentor is using language models for its creative ideation on the solutions for the issues that it finds. Like, this looks like a good one. I think many of us have already seen is, so this side is our deterministic AI that is pretty principled. It will always find the same issues, whether it's running here or on someone else's machine, in the cloud, locally, all that stuff. But this piece is more of the creative ideation that's going to solve this in a variety of ways. And you can see there's one solution and here's another solution. You can tell this is realware because I don't know what this big gap is. Clearly, we've got more work to do. So yeah, early stage startup. Third solution looks very similar to the first solution. Is it the same though? It is not the same. It's different. That's cool. That's very interesting. Just trying to one. Okay, cool. I was just trying to quickly check for correctness, and it looks like it might have gotten it. And then fourth solution, different again. So you can use language models, I think, but again, the way that I think about this and the way that I teach it and how we build it at Merly is the logical system has to be foundational to that machine programming system. And then from there, you can add various things on top of it. Okay. So we'll read a little bit more and then we'll get into the AI slop stuff. Okay, so I've been sharing that they had a great talk with Kelsey Hightower. Don't rob yourself of the basics. Put differently, this can be a great accelerator. Vibing takes away so much. Yeah. No, I absolutely, Ivan. And to double down on what Kelsey is saying, and Kelsey, I think, is like former principal engineer or very senior level person at Google. Is that right, Ivan? Something of that nature. I don't think I know him directly, but I've heard really good things. In the general life goals, I think there's one of the things that I talk about is this part, mastering the basics, how I think it's just so important. And to take that away from people, I think I think we're doing ourselves a disservice, because these things are fundamental, especially as we iterate. As we iterate on these solutions in code, which is, again, very different than things that are like one shot, where Like, for example, let's say I have an AI system that's going to vacuum the house. So it vacuums the house, and then it's done. And I think, okay, well, is it perfect? Yeah, not really, but good enough. But with code, it's iterative, right? It's you write the code and then you iterate on it and you iterate on it and you iterate on it, because that's the nature of code. We don't just like do it once and we throw it away and then write it all from scratch. And if you don't believe me, you can just look at any piece of software that is being used in the world, like Kubernetes, and you can say, wow, yeah, they've been working on this for 10 years and they're going to keep going. Same thing with Linux, the Windows operating system. So it's not a one and done kind of thing. And because of that, you really need the principles of iterative refinement. And if you don't understand the code, like I think you pointed out last time, Ivan, you're likely going to end up in a spot where you don't know what's going on. And then when you have bugs or you have features that are missing from the system, and the AI itself couldn't fix those bugs, how then would it fix those bugs if it couldn't fix those issues when it generated it the first time? And on top of that, like we've discussed with stochastic AIs, the problem is that iterative refinement limits their ability to have version 2, version 3, which is improvements, rather than just whack-a-mole. Is you go to fix one bug and then 10 new bugs emerge and so on and so forth. Like that's basically why a lot of people are arguing that the AI systems are getting worse, not better, if they're just using language models. And actually goes to our AI slop conundrum. So one last thing we'll read about. That just makes me laugh. Warp drives. Indeed, for Gotchlik machines that can code better than humans are going to be essential. For him, that's the only way we'll build vast, complex software systems that he thinks we'll eventually need. And truthfully, I do think that we need them to be as precise and correct as calculators, especially for those critical systems that we're going to need for spaceships and operating systems. And I do think we can get there if we have systems like Merle's AI at the base. And it doesn't have to be our AI, by the way. Like you can build deterministic AIs in a variety of different ways, like logistic regression, linear regression. K-means clustering can be made deterministic. It is inherently stochastic based on the cluster range. But anyway, you can do certain things to make machine learning systems deterministic. And when they're deterministic, then you can use them the way that we've used science historically for things like the scientific method, which allows for iterative refinement, and we fix the bugs in the equations. We don't just throw it away because we don't understand it. But with these massive neural networks, it's just a whole bunch of wires and it's a whole bunch of stuff that we look at and we're like, yeah, I don't know what that does. Do you know what that does? It's like, I don't know, Bob. What about you, Alice? Nope, don't know, but why don't we just throw more data at it here and cross our fingers and do a little dance and maybe something cool will happen? Like, this is no way to do science, guys. It's not great. Okay. So like many in Silicon Valley, he anticipates a future in which humans move to other planets. It's going to happen. Okay. Call me crazy now, but just wait. That's only possible if we get AI to build the software required. He said Merle's real goal is to get us to Mars. Goju prefers to talk about machine programming rather than code assistance because he thinks the term frames the problem the wrong way. I don't think these systems should be assisting humans. I think humans should be assisting them. This is actually true. Oh, wait, I have a quote here. They can move at the speed of AI. Why restrict their potential? Yeah, this is very much how I see it. Like the way I think we use these coding systems today is sort of nonsensical. So we have supposedly these super powerful AIs. By the way, I understand why it's done this way, and it's mostly a technological limitation of language models. They need to be instructed what to do because they aren't computationally fast enough and efficient enough to function at the level that like Merle's AI can function. And so you have to give them this specific task so they can focus on that one specific thing. But the AIs, in theory, have this unbounded potential. And if that's the case, why not just let the AI do what the AI can do? And the humans can sit back and just check to see if what the AI is doing is the right thing. So the analogy that I gave Will is, yeah, there's this cartoon called The Flintstones where they have these cars, but they only move when drivers use their feet. True story. This is how the Flintstones work. And this is how I see people using these AI. So you say, hey, here, do this thing, and then rewrite this whatever. And then they do that thing. With Mentor, you don't do that. What you do with Mentor is you say, here's a repository. And then Mentor says, okay, I'll take it from here. And then it does its thing. And then after several hours of doing its thing, it comes back and says, okay, do you want to talk about it? And it says, okay, here's stuff that I learned. I learned about this. I learned about this. And here's the things that I found that you should fix. By the way, I've come up with solutions to all these things, right? So this is the way that I think the AI should work. They should work at the speed of the AI, not at the speed of the human. Now, I realize that most of the companies I think that are trying to do these code assistants, the reason why they're doing it that way is, again, language models have a computational tractability issue. Is you can't just unleash them on the code to just do the stuff that Mentor can do, because it would take them like 10 years. Whereas Mentor, you can unleash it on your repo, and then not only will it look at the current code, it'll look at the whole lifetime, and then it'll start to just figure things out. By the way, the other thing that is super important, as we've discussed in many of the former VODs, is in order to really do advanced superintelligence types of solutions, what we really need for these AI systems is the ability to reason temporally over a repository's history, because then we understand things like intention, not just semantics, but the intention of the developers, the intention of what is being built by the software. And I can give like a 30-hour oration on that, but I want to get into the AI slop. So I promise I'm going to stop once we get to, yeah, I think we're almost there. Okay. But what Merle's building is essentially spaceships, not joking. And I don't think spaceships should be powered by humans on a bicycle. I don't. I think that's how a lot of the other companies are doing this. And I don't fault them, because they're doing the best that they can for the technology that they have. I just think it's the wrong technology. Like I think that we shouldn't be building cars that have no engines and then powering the cars with our feet like the Flintstones. I think we should build cars that have their own engines, that the engines can then drive the cars. If that sounds wild, it is, but there's a serious point to be made about what the people building this technology think and the end goal really is. Goju is not the only outlier in his galaxy brain take. Despite their focus on products that developers will want to use today, most of the companies have their sights on far bigger payoffs. So yes, I'm not the only crazy one. There's other, crazy ones out there. Okay, cool. So that's basically the MIT article. I'll continue to contact them and ask Will to kindly remove the paywall. But now you got to see a little bit of what this thing talks about and how silly I am, even when I talk to my buddies over there. Okay, now I want to quickly get to a little bit of this AI slop conundrum thing. And the real kicker is what we discussed last time on model collapse. So model collapse is this notion that as the AI models continue to evolve, if you train them on their own outputs, they can never improve beyond the current state that they're in. And instead, they kind of are getting more and more overfit, and they eventually collapse into sort of just being nonsensical. You can kind of think of it as like if you are in an echo chamber and you're just talking to yourself, and over, you have no external voices that are increasing your vocabulary. You have no additional forms of knowledge. And so you're losing bits of your own knowledge and yourself as you continue to just talk to yourself. And then suddenly you're not even saying words anymore. It's just sounds and grunts and whatever. And I haven't looked at this article. I just liked the title. I found it right before we started the stream because it hints at the notion that we discussed last time. So AI models show signs of falling apart as they ingest more AI-generated data. All right. So as we saw from the Register article, and if you haven't seen that one, then I strongly encourage you check out. Whoops. Let me just stop this. Pretty good, but stop. Check out this vibe coding is over one, because I think we talk about. Is that the one? No. Sorry, it's this one. It's the AI model collapse and copilot delusion. In this article or this VOD, we show this Register article that talks about the model collapse and how it's much more complicated than it may appear at first glance. So going back to this, at first glance, it may appear like, oh, okay, so you have AI models, and then they get worse if they ingest AI-generated data. So the simple solution is don't have the AI models ingest AI-generated data. Duh. Yes, I agree. But how do you do that? How do you do that when it's becoming harder and harder to delineate what is AI-generated data and what is human-generated data? That a lot of the data that we're seeing in the internet now is actually coming from these AI systems. And in fact, if you go to Mentor, there's some very strange things that we're starting to see with source code that's making us like a little bit nervous. One of those is Microsoft's Visual Code. Now, this red line here, these are the number of issues that Mentor has found. This is Mentor's AI finding these issues. And generally speaking, what you want is to see this kind of as a straight line or a line that's decreasing, not increasing. This teal line, this is the lines of code. And so it's understandable, I think, to some degree that you're seeing sort of a proportional relationship between the issues and the lines of code. Again, if it's really hardened code, if you look at something like Git or Linux or Kubernetes, you're not likely to see this. You're likely to see the issues kind of taper. Yeah, it gives me nightmares too. So this is not great to begin with, right? But let's skip past that part and let's go to this part, right? What is happening here? This is something up until recently I had never seen before. And keep in mind, Merle's been around for about 3 years now. And admittedly, it takes us a while to build our machine programming systems because we build them from scratch. So we're not just downloading a model from Hugging Face and then slapping a UI on it. Not trying to be judgy or anything. That if that's your business model, that's great. We're just approaching it differently. But in the 3 years we've been looking at code, we haven't really seen this stuff until recently. And the timing of this is really interesting in the sense that the code generators have been in play around this time. And on top of that, as we discussed in one of the other VODs, we looked at the net negative on Cursor's homepage, and we took a look at the fact that what Cursor was recommending as like good code was basically stuff that my undergraduate students at the university would likely do a better job in writing. And this is like the code that they're promoting as the code you should use on their homepage. This wasn't like, and I didn't even write this article. This is Lucas Atkinson who wrote this a few days ago, which I've since fallen in love with. And it's, I think, a really fantastic piece. And I also think that he's not trying to be against coding assistants. I think he's just trying to tell it to you straight. Like, if this is the best Cursor can do, and you actually know how to code, this is really bad. This is stuff that we would never let fly at Merle, and I can't imagine anyone that deeply cares about software would allow these things to get into their code because of that idea of iterative refinement, right? So going back to this article on this generated data, I started thinking about this, and I got to be honest, I don't know what the solution to this is. I have some ideas. So first of all, the first thing that we need to do is we need to get away from self-supervised systems that use ground truth as their mechanism for learning. I think this is probably the first thing you want to do is self-supervision is key, but not ground truth. You can't, if you use ground truth, you're basically cooked. So don't do that. And I think many of, if not all of, the AI systems that are coming out from big tech have traditionally used ground truth data, and they're cooking themselves. Because as we discussed last time, not all data has the same level of fidelity. Comments that you see on Twitter are not at the same caliber as peer-reviewed research that shows up in Nature or things like that, or at NeurIPS. So you really want to get away from this notion of ground truth and instead use something like semi-trust, which is a gradient-based spectrum of fidelity, quality. Whoops. But it's not as easy as just using semi-trust, because you have to figure out how to generate the semi-trust algorithm. So I can say this very easily, but actually building this is pretty challenging. The other thing is that, can we identify AI-generated data and this piece? Not all synthetic data is the same. This piece I think is super important to understand, because when you have something like the DOTSA system, which is a synthetic data generator, it is not the same as an AI data generator in that it's human controlled. So it has stochasticity, it has randomness, but the humans are specifically programming the degree of stochasticity, and it's quite intentional. So this is why I think that it's not all synthetic data that should be seen as like AI slop. On top of that, different systems, I think, have different levels of fidelity. Different AI systems may be producing higher degrees of semi-trusted code than others. But minimally, I think that, like, again, I'm very confused about this. I don't want to give anyone the impression that I think I have a solution, because I don't. I don't have a solution. I just started thinking about this, and this is going to take us some time to figure out. What I do think is that minimally, one of the first things we need to try to figure out is how can we determine if data has been generated by an AI system. So not just non-human data. I'm specifically talking about AI generated data that is functioning with some level of autonomy. There are other synthetic data generators like Datsa or many others that people have built outside of the ones that I've been working on that could have significantly better fidelity. And those data are different than the AI model data because it's not contributing to AI collapse. This part's super important to think about and reason about, because the model collapse is that principle of the echo chamber. It's this notion that you have like a single voice, and the single voice is just making things go into a black hole, and then you're cooked. If you have a synthetic data generator that's not from the model, it's over here. Like, you can expand this, right? This is, again, why I'm saying that not all synthetic data is the same, that we shouldn't prescribe all synthetic data generators as bad, because I don't think that's accurate. I think that what we don't want is the AI models to be training on their own output. I think that is extremely dangerous. And I think, based on what I know in machine learning, having worked in this area for quite some time and teaching this and, running Merle on this, this is almost guaranteed in my mind to cause essentially black hole events for these AI models, is that they will essentially collapse into nothingness. Like, it's no surprise to me that DeepSeek's model is a subset of OpenAI's models, because if it were trained solely on OpenAI's model outputs, which there seems to be some degree of substantiation to that claim, it can never be bigger than OpenAI's model, because it's only ever learned. It's like if a child is only ever trained by one parent, that child will never know more than that single parent. Therefore, you need the child to learn from all these different sources, right? It's the same principle here. So this idea of regurgitating from the AI model parent and just using that in perpetuity, terrible idea. Terrible idea. So minimally, we don't want that. And in order to prevent that from happening, I think that we need some mechanism that will help us delineate between AI-generated data. This would be the starting point. So at worst case, the models themselves can avoid those for training data. By the way, I'm not even talking about machine programming now. I'm talking about the whole field of artificial intelligence and generative systems and the way that you train them in a self-supervised fashion. I'm talking about everything. For machine programming systems, in some sense, I think that we are in a much better spot for a variety of reasons. I don't want to go into all those reasons. But if you're a highly skilled programmer and you look at something like this and you understand Git and you understand timestamps and you understand when these cogen systems were invented, you likely already have some inclination on how to train and learn from data that's, for the most part, guaranteed to not be AI generated. Unfortunately, the rest of the world may not have that superpower. So I don't know how you do this in all domains. It's something that I think we'll have to think about. But I wanted to talk about this because this is a conundrum now that we now are in. And when I say conundrum, is that this is nonsensical. We have these AI systems that were originally trained on a large corpora of data that is out on the internet. And then the idea is we'll just continue to perpetually train on all the data out in the internet. The problem is a large majority of that data is data that they have generated. So now they're going to suffer a model collapse whether they want to or not. And part of it is their fault in that they didn't have watermarks or specific types of stamps to say this is AI generated data. If we would have moved forward with that care, this might have been an easier problem. And it's amusing to me, I mean, amusing in a really sick and twisted way, that it's like their fault, that they are the cause of their own conundrum. Again, moving really fast and breaking things can have consequences. And so I'm not going to mention any names here, but I think some of us know where a lot of this came from. And so now we have consequences, and that the AI model fidelity improvement is not likely going to be nearly as simple as one might anticipate. And it doesn't matter. It literally does not matter if you 10x, 100x the model size and ingest 1,000 times more data, because it's that parent-teacher thing, right? So you've got the parent and it's teaching the child, and now the child wants to learn more, and it's going to go talk to the parent, except now the parent is learning from the child. And so it's this just garbage in, garbage out, and the child is actually getting dumber, not smarter. So we have a very interesting problem on our hands, and this is going to affect, I think, every domain that is using AI. This is, I anticipate that this is going to be like I don't want anybody to panic here. I keep this tab open to remind me constantly of a place that I don't want us to go. I do not want us to go in this place. And the more I think about this, and keep in mind, what's done is done. We can't undo these things. These things have been unleashed. And so now we need to figure out a way, a very intelligent, curated, high fidelity way to avoid model collapse. And like, based on my limited time thinking about this, there is no obvious answer. I wish that there was. I'd just be like, oh, just do this. I'm not seeing it. For machine programming systems, I have an idea, but for the larger space, like, for example, news articles and yeah, it does. I'm not sure. I mean, you could use dates on articles, but as I understand it, those techniques, I think, have been done. And yeah, I think it did, Ivan. Ivan's commenting that didn't Google remove cache from its searches. And I think that I heard similar things. And because of that remove, and whether or not, so I think publicly Google has stated that it's done that. Whether Google has actually done that in reality is, I think, a slightly different question. But this is something that I think we need to, as a community, rally around and try to understand. And again, for machine programming, I think that it's not super, there is an easier path forward in some sense, but it's the other domains that I'm more concerned about. And part of the reason why I'm concerned about them is I don't want AI model collapse. Like I would like these systems to get better. And I'm not even thinking about just them being language models. I'm really thinking about them being really kind of any machine learning model, because as you know, the best I can tell, it wouldn't be limited just to language models. It would be essentially almost any machine learning system. Like this is part of the area that I spent a lot of time working on, which is anomaly detection. And so, as I mentioned in one of the former episodes, one of the big automobile clients we were working with wanted me to help them with my expertise in anomaly detection. And principally, what they had told me is they didn't care about any non-anomalous data. They only cared about anomalous data. And I asked them why. I mean, I had an inclination on why, but they said because anomalous data is the only data that will help improve their model quality, which makes sense. Like, if you think about it, like they've seen all the normal data, they've trained on all the normal data. Well, what's left? Just the outliers, just the anomalous conditions. They need those now because those are the only ways that they will like get these improvements. It's sort of like the way that science evolves is, right, we need new ideas to push the boundaries of science to like expand our knowledge. We don't need someone to say, hey, I invented this thing and it goes in a circle and you can move stuff with it. And people are like, that's a wheel. We've had that around for a while. And it's like, yeah, but isn't it cool? Like, yes, this is very cool. We have that already. Like, let's do stuff that we haven't done. So you really need this novel data to expand the model's capabilities. And therefore, that would preclude any of the AI data because by definition, it wouldn't have novelty in terms of like its like true ideation. Now, I want to back this up just a little bit. There is some debate like in the scientific community that there's sort of like these generally two types of novelty. There's like what some people would consider truly novel ideation, where it's like this hasn't been thought of before. And then this idea of novelty by composition. And it's basically you take things that exist, you put them together in a new way, and then that is novel. Yes, I do think that AI systems can do this second form of compositional novelty. And I do think that has value. But then notice that once that compositional novelty has been explored, it's no longer novel, right? And there's only so many perturbations of that tree before you run out of novel examples. You really, that first form is the form where like quantum physics in addition to Newtonian physics. That I think is an example of like true ideation, at least based on my limited understanding, is like, oh, this just is total departure from the existing physics that we have from Newton. And it adds in a way that expands our just understanding of physics in this very profound way, where you don't necessarily get that same type of evolution in science if it's just compositional novelty. Like, I don't know that you get quantum physics when any form of compositional novelty from Newtonian physics is what I'm trying to say. So anyway, I think that probably is sufficient for this stream. I didn't get to the drama in the Linux Foundation, maybe I'll do like a quick Google on this. What do we want to say? This is what is this guy's name? Yeah, it's something. Oh, here we go. This is us.
Today we have a big one.
This is the one I want to talk about. And I'm going to save this for next time. But here, this is our teaser. This I just heard about this last night. So I think I was actually watching this clip. Yeah, I like this already. So yeah, feel free to give this a like and a sub. I'll do both myself. And this is a good follow-up because this is more going to focus just on our personal, being a good citizen and doing the right thing. And one thing that's really interesting about this is this notion of fostering goodwill. And I want to say that I don't know that Linus is not fostering goodwill because of the way that he says these things. So I want to just jump forward a little bit so you can see what I'm talking about. There's certain words that we use. And by the way, this is like total shift from technical, even though this appears technical, I'm going to actually talk more about the personal and like qualities here. Is there's a way to phrase things where you can question things, but you use weak claims. You don't use strong claims because you are still sort of fostering goodwill, but things look dubious. So, okay. So, I mean, honestly, if when you get to what actually happened, I might start this off myself. But he says this: you seem to have actively, maliciously modified your tree completely. Notice that he says you seem. He doesn't say that you have done this. It's just you seem to have. That is saying that I don't have concrete evidence, but this is what it looks like, and this is not super great, right? And so he's going on and talking about how one of these things says this comes from me, and we need to nuke this, and I'm going to refuse this. And okay, so this sentence I think too is also really good. To be honest, like again, I've been taking a little heat from some of the Jeters because of my constant praise of Linus. But look, I've been in similar situations, and one of the things that I love about Linus is how much he cares. It's his care. Is this a little harsh? Possibly, but he really cares. And what is going on here? Like, we don't know, and we need somebody that cares so much. Like, again, maybe the messaging isn't perfect, but if Linus doesn't care, who is going to catch this? And what happens if it's not caught? Like, Linus wasn't around for the XZ exploit, guys. If he was, maybe that doesn't happen. So I mean, like, if you look at it from that perspective, there's a lot of good things that happen from people that really care. So I will now refuse to pull anything from you until you explain what you've been up to, because this looks like you've been doing actively bad things. Notice again, he doesn't say you're a bad actor. You are malicious. And this is super important in my mind because it appears like it is, but he's still actually fostering goodwill. In my mind, he is still actually doing this. The reason why is that he's still talking to this person. He's still giving them a chance to explain themselves. If he were not fostering goodwill at all, this person is just basically dead to him. He's not communicating with him. He's banned for life. He's sending these things privately. This guy is just gone. And he is freezing his account, and he is halting on this. But he says, again, because this looks malicious. And he's not saying this is malicious. He doesn't know yet. And I think that takes incredible amount of restraint. Like, imagine if you are Linus right now and this is your baby and something is like this is happening where you're being credited on some of these like bogus commits. I might be a little fiery too. And in fact, when I was younger doing Nautica, I said stuff way worse than this. And it wasn't this looks malicious. It was like, this is malicious. You're gone. And then I was wrong. And so I think that it may appear like there's not a level of maturity in his response. I think there is. I think that he's probably very concerned. And I think for very good reason, given what has been going on from potential nation state attacks, from various bad actors who I think those of us who know, we know. And if you don't, just spend some time Googling it. There's a really good reason to be nervous, I think, about this and pay a lot of attention. So anyway, we'll get into this. This is the teaser for this. We'll spend maybe a full hour or two talking about this. And the high level takeaway is, as I think I've mentioned in these general guidances for life, the way I talk about fostering goodwill is very simple, is that my view is you foster goodwill until you no longer can. You always foster goodwill right up until the point to where you no longer can. And you no longer can when someone tells you, no, I actually am trying to be malicious. I'm actually trying to be a bad actor. And you'll notice that the response that this gentleman gives is he doesn't say that. He's basically saying is like, it was an accident. I don't know what happened. It was a rogue SSD. I mean, I've had many rogue SSDs and I have seen them corrupt things. Could it happen to this degree? I don't have enough data, so I don't want to. I'm not trying to create a witch hunt here, so I'm not going to make any claims. But this is his initial argument, and I think it's a good example of Linus being careful on not assuming that he's a bad actor, because there is a chance that this could just be a misunderstanding. And, you know, it sounds like minimally Keith should have said, oh, hey, I had this massive SSD failure that I had to patch all of this tree up and I probably got some I mean, like, I might have opened with that. So then when people look at it, they're like, oh, okay, so that explains, because when you do it after the fact, it again, it has an appearance of being like you're trying to pull a quick one, and that's not super great, especially given stuff that happened last year. So, yeah. Anyway, that's for next time. So for this time, I hope you guys enjoyed this. We've got a real problem on our hands as far as stopping model collapse. So I hope that together as a community, we can work on trying to solve this. I don't have the answer to this. And in some ways, that's part of the reason why I wanted to talk about it, is I'm actually very interested now in this problem, and it changes things in some sense. And as you can see, I think that it's happening in code already. And this isn't the only one. We were looking at OpenSSL. Look at this. OpenSSL was on this trajectory, but it's continuing to go. And I don't suspect these are like the only ones we're seeing. I think that there's likely going to be a lot of stuff coming our way. So the conclusion, I think, is now is the time more than ever for us to be focusing on quality. I thought it was a good idea to focus on quality for code, just because, I mean, that was the original charter for machine programming. If you look at some of the earlier talks I gave and the discussions with various news outlets and stuff, keynote I gave at Penn, I talk about machine programming being about improving the speed of software development and improving the quality of the software that it generates. And so Merli was just founded on those principles. So it's always been in the back of my mind. I didn't realize that this was going to become this big of a deal. I guess it kind of makes sense now. I'm just trying to be honest. Like, I didn't expect it to go this badly, but I'm really glad that we have something that can hopefully at least help with the machine programming space. But now, as good global citizens and experts in AI, minimally, I think we should try to ideate on how to potentially solve this for the larger community, so then they can try to improve their models from this black hole conundrum that I think maybe they're heading toward. So, fingers crossed. All right, everybody. Thanks so much for joining. Happy Monday, and I'll be uploading the 4K version of this shortly. See you, Jeters.